Hey everybody, thanks for coming. Did everybody hear me all right? Yep, okay. We have a few more seats up front. Like we said, beer and wine over here, soda in the back, water over there, pizza in the back. Welcome to Continuous Delivery NYC. This is probably going to be our last meetup of this year because we're going to take December off, but we'll be coming back in January with a whole new line of speakers. If you've got things you'd like to see at Continuous Delivery NYC, shoot me a message on Meetup or just get in touch with me afterwards and let me know what kinds of things you'd like to see, and I'll try to get those scheduled for next year. Additionally, one of the things that we find at this meetup to be the most approachable for everybody are true war stories from the people in the room. So if you've got a war story that you'd like to tell about continuous delivery, continuous integration, your journey in that path, in that direction, we'd love to hear about it. We've presented ourselves. And so, yeah, just connect with me and I will set things up. I don't think I introduced myself, though. I just jumped into it. I'm Daniel Rolnick. I'm the CTO here of Shopkeep, a tablet-to-cloud point of sale. If you're interested in point of sale or anything about helping small businesses, come talk to me. But without further ado, I'm going to hand it over to Andrew Phillips. And thank you very much.
Thank you, Daniel. Thank you, Shopkeep, for the pizza and the wine and the beer. I have to say, they did get me with the slide. What is a return ship? And there was some position, like a software engineering return ship, which I'm sure Daniel can explain, but I'm curious. Anyway, they got me with that one. Interesting.
Hold on, Andrew. So to explain what a return ship is, a return ship is the concept that somebody may have exited the workforce to take care of family, like a loved one, with a medical need or a newborn, and they are finding it hard to get back into the technology field. Maybe they were in the military, something like that. And so what we're doing is, if you've got experience in technology, we're not discounting that, even though your skills may not be fresh. So come talk to us, and we'll help you get back into the technology field.
Great. Thanks for explaining. Yes, very worthwhile. I think our industry can do a lot, certainly in that area, to do better, but I digress. As you can hear, I have a bit of a cold, so I'm a little blocked up. And I'm trying to drink a lot of water to make that better, but that obviously sets up an uncomfortable balance between me having to run off to the bathroom halfway through this. So I hope I'm going to get this right. A quick public service announcement before I do start. It sort of only doesn't apply to me. There's elections coming, for those who haven't realized, in a couple of days. Whatever part of the spectrum you're on, please vote. It's really important. Whatever your vote is. That's the last political thing I'll say today, but I think that is very relevant. Okay, so tonight, title of the talk, From GitOps to an Adaptable CI/CD Pattern for Kubernetes. We'll talk a little bit about what adaptable means by this and why I'm setting this up. I think a slightly alternative title, which is interesting, is that if you think about it, a lot of what I'm going to speak about isn't really specific to Kubernetes. Kubernetes brings a lot of ideas to the fore, and GitOps does as well, but actually, I think there's lots of what I'm saying that could apply equally well to many, many different types of software delivery. I'm not going to try to make it too theoretical, but I think there's definitely an angle here that isn't entirely Kubernetes specific. Let's start with a quick show of hands. Who here has heard of the term GitOps? Okay, about half the room. Who here is doing what they would consider to be GitOps style software delivery, like CD? Well, small number. I hope, not surprised by this, I hope I have something for everyone here, in the sense that for those people who've heard about GitOps or who are already doing it, there'll hopefully be some detail about how to think about it maybe a little differently, how to expand it out. And for those who haven't heard of it yet, fear not, you don't have to have heard of GitOps for this talk to be meaningful to you, hopefully. The concept, I think, is very meaningful, even if you haven't heard of the idea, and so on and so forth. All right. Yada, yada, yada. Just so the people who look at this slide later on SlideShare or whatever will see. Essentially, I've suffered around most parts of this space. I've been the developer. I've been the owner of the platform. I've been the PM, et cetera, et cetera. Done a bunch of open source work. I now work at Google, but that's unrelated to this discussion here. Obviously, that means I spend a lot of time thinking about Kubernetes, so that informs some of what I'm saying. All right. So let's start out with a quick, how am I trying to break this down? I'd like to set the stage by talking about what the actual problem is, I think is worth talking about. And then frame this discussion by not diving straight into Kubernetes or GitOps, but by talking about what we consider to be good practices in CI/CD or in software delivery. And then how Kubernetes adds a new direction into this discussion, or how it bring some new ideas to the fore, and then how you combine what we already know with what Kubernetes does, plus how you can evolve this going forward. And then potentially lots of questions where everybody's head will have exploded, and then we'll just be done for the evening. So what's the context here? A lot of organizations, let me rephrase this first one a little bit. A lot of organizations are doing some kind of thing to change the way they look at software delivery. You know, you might be in the middle of a digital transformation, or you might be going to the cloud, or you might just be looking at Kubernetes or Fargate, or put it this way, I mean, you're here at this meetup, so there's a lot of people who are figuring out changes in their infrastructure, in their software development practices, how they run and build and deploy applications. And obviously, again, from my day job perspective, I see a lot of that through the lens of people looking to adopt Kubernetes, either standalone or as part of a microservice thing. It's fair to say it's the platform du jour. Will definitely be replaced by something in the future, but for now, it's the hot thing. And of course, what happens when people look at a change in the way they deliver software? Well, they want to do it better than they did last time. CI/CD is that inevitable area where everybody says, yeah, I know it's not great, but we'll do better next time. Because, you know, you get the duct tape in place and you glue it all together and the stuff barely works, and then you get on to more interesting things like actually writing code. And so people obviously ask, no, this is the opportunity. They feel that they're now adopting something new. There's a great chance to do things better than they did last time. And so people want to know how to do it right. And nobody wants to do the duct tape and baling wire and ball of mud and all that kind of stuff. That's just where we typically end up because it's hard to get it right. So why is this difficult? I mean, it's not like software delivery is a new thing. Like, I had many discussions over the years with people who do mainframe software delivery, super sophisticated, way better than most of the hot swapping of code in runtimes, all kinds of amazing stuff. But, so it's an unsolved problem. But of course, when you adopt a new runtime like Kubernetes or whatever, there's a whole ton of new concepts that you have to get your head around that you haven't seen before. And there's a new community, and they come up with new practices, they think of new things, and sometimes these new things are meaningful, and sometimes they're just because not invented here. But as a community evolves, these ideas get fleshed out at the beginning of everything. Nobody knows exactly how it's going to work. So if you start out by saying, oh, I want to do this the right way, I want to do Kubernetes native delivery, part of the problem is that nobody knows exactly what that means because it hasn't been figured out yet. So you're trying to wrap your head around new runtime concepts. You're trying to wrap your head around new concepts around how to deliver stuff. And then you're trying to go from a blog post that somebody wrote about how they happen to do it in their particular Snowflake environment to something that might actually work in your setup, where you have different teams, or you have regulation, or you're not using the same version of Kubernetes, or you don't like Helm, whatever. So you're trying to wrestle all this around in your head, and you clearly don't have all year because probably your boss wants stuff to get shipped at some point. And then you're trying to tie that back to what you know about how to deliver software well, like the pitfalls that we've had in the past, the times we've burnt ourselves, and wrangling all this together is very difficult. And the failure mode here, as in any new space, is what I call, cargo cult all over again. Like, our industry is littered with, there's this new thing, and I don't have time to understand it properly, nobody's explaining it properly, so I'm just going to copy this blog post and then I'm going to move on. Like, agile, water scrum fall, everybody who's been through one of those agile adoptions where somebody buys 5,000 post-it notes and make everybody stand up, but you still do 6-month development cycles and all that kind of stuff. Like, we know this stuff. This is nothing new. I see people smiling. And there's a big risk. This is not specific to GitOps or Kubernetes. It's like any new adoption space. There's a risk that this will happen here as well. So one of the things I'd like to talk about today is to hopefully give you some understanding, some connections with existing practices, and a mental model so you can decide whether this is a good thing for you, and then how to tweak it for your particular scenario. Like, what's important, what's just an implementation detail. Of course, I'm not claiming that I've got this right. I mean, I've thought about it a lot, and I've spoken with a bunch of colleagues who spend way more time thinking about Kubernetes than I do. But this is a community effort largely. These are ideas we're putting out there to hopefully make things better for everyone. So what are we going to try and do? We're going to remember some good practices about software delivery that we shouldn't throw away. We don't want to throw the baby out with the bathwater. We're going to try to add some elements that Kubernetes introduces into the mix. We're going to come up with a straw man. It's not the only way to do it. but a way to do it that is, I think, a good starting point for your evolution. Then we're going to talk about how to think about that straw man. And then we're going to finish off. I'm going to do some demoing using a nice command line setup that I have, talking about how you can evolve this straw man in directions that make sense for your scenario. And then there's tooling. I'm not going to talk much about tooling. There is some tooling in this space. I'm happy to have a long Q&A about anything from Kustomize to Helm to Jenkins X to 10 million different operators that are out there that try to embody some of this pattern. I think we're still at the early stages where they're not very flexible, and so they take a very opinionated stance, sometimes with the wrong opinions. But I'm trying to stay a little bit away from saying you should use tool X or tool Y or tool Z because they do it perfectly. All right, set the stage. So what are good practices that we've learned? The first obvious one is that we want to do reproducible builds. It's nothing surprising. We have source code, and we want to find a way to turn that source code into some compiled stuff. And we want to do that in a reproducible fashion so we can be sure that we can do it again. But also that we typically don't just store the source code. We actually also store the compiled code. This sounds totally trivial. If you have Java, you store your Java source code, and then you have a jar file, and you put it in a repository, like Artifactory, Nexus, whatever. So what does this have to do with software delivery? Well, config, like YAML files, piles of YAML, in a Kubernetes environment or in any declarative environment is another form of artifact. So we should think about that as well. We want to minimize duplication. Everybody knows the classic, I've got 5 properties files, dev, test, staging, validation, production, and I need to make a change, so I have to copy paste through all those 5 files, and then I make a mistake, I miss the one file. Not good. So we want to minimize duplication where we can. I think, so the next point is a little opaque. A lot of the space around software delivery is arguing right now about whether declarative or imperative is better. Imperative's bad, declarative's good. I think that's a false dichotomy. I think it's not so much about whether imperative is good or declarative is better or whatever. It's about recognizing that if you think of your deployment process going from a commit to your source repo to through a bunch of environments and eventually into production, it's really 2 different things. There's a business process, which describes how you get from dev to test to staging to production. And then there's automation, like how to actually deploy to the dev or the test environment. One of those is highly automatable and really should be standardized. Like you shouldn't have to write big shell scripts to do your dev deployment. And the other one is a business process. Like Kelsey Hightower has a nice tweet where he says, CI/CD is encoding your company's culture in bash scripts. And I think that was a slightly pejorative statement. I think the proper way to look at that is to say that part of software rollout is a business process. So it cannot be standardized because it's entirely dependent on your business context, on the type of application you have, on the type of users you have, on the type of risk you're willing to take, and so on. There's 4 processes that all of us know about. They're not, typically when we talk about CI/CD, we only think of the first one, updating an application. But there's really 3 others that we all have to do at some point in some way, shape, or form. And I think it's very nice if we can support all of those with the same automation setup. So an application update is one, but environment config update is another, like changing the log settings in staging, for example. You don't want to have to run a whole end-to-end, rebuild all my containers, deploy to staging, then abort the production deployment just to change a log setting, right? And then, of course, you have your classic disaster recovery, spin up, restore of an entire environment, which is usually thought of as an operational process, but requires a lot of the same data. And then, of course, there's the famous drift detection thing. How do I understand whether my environment is actually still in the state that I want it to be? Right, so we'll talk about the bottom one a little more. It's like how to do this from the same setup, really. So this is what I was saying a second ago when I talked about the business process and the env automation. I think a nice way of thinking about, this is how we traditionally do software delivery, right? We have a bunch of environments, and we have code that goes into the left-hand side, and we have some tool at the top, Jenkins or shell scripts or whatever, and that defines how we flow across those environments. There's lots of deployments in there, but there's also lots of other stuff. And we typically call out to the various environments to make stuff happen. That can be nice and sophisticated with Terraform or with Kubernetes, or it can be nasty with shell scripts and manual stuff and whatever. But this is kind of how we typically do things. Right, I've talked about these. I'll get back to this in a second because I'll talk about what Kubernetes introduces as a new layer. Let me just skip forward. Yeah, ignore the bit in the middle. I think this is this getting rid of this imperative versus declarative. It's imperative at the top and declarative for the bottom ones. Of course, you can't, realistically, technologically, we don't have enough declarative tooling to support full automation of the bottom layer. You know, as soon as anybody says, oh, I have to update my database, all the declarative nonsense falls apart immediately. Oh, yes, also need to run a shell script. It's fine. Like, so anyway. I've talked about these four already. I'm not going to belabor this again. I just want to give them phrases so it's a little clearer what I mean. Application update is what I said. I've written some new code. I'm going to make a release candidate. I'm going to try to promote it from dev through to prod. Environment config update, that's pretty obvious. Environment spin up restore is I've got a brand new Kubernetes cluster. Make it so. Or my old Kubernetes cluster died in a fire. Here's a new one. Restore it quickly. And then you've got the detection and remediation. Maybe something to point out here is that most declarative systems, Kubernetes included, doesn't give you a choice here. It does remediation by default, right? It says, like, if I detect a difference, you don't want it that way, I will stomp on it. I think if we think about software delivery in a more general sense, it's often very smart to have a choice between whether you want to actually stomp on everything or whether you just want to be told that something has changed. Because then you can panic, you know, do whatever you want to do. Anyway, so what does Kubernetes add into the mix? So far, most of what I've talked, yes?
Can I talk about drift detection? Does it include like schema changes in the database?
So because it's being recorded, let me repeat the question. When you talk about drift detection, does it also include things like schema changes? It's an excellent question because it really, I think the way to answer it is to ask, how much does your declarative thing cover? Right? Most of the time, drift detection, the point behind drift detection is you have a description of what you want the state to be, and you have some mechanism for detecting what the actual state is and reporting on a difference. In order to do that with a database schema, you have to store the desired schema state somewhere. And I think if you do that, then there's nothing conceptually that would prevent you from doing this. I think most of the time we don't do that. We don't actually think of the desired database schema state as a set of files we should put in a repo. So let's talk about that in a little bit. So what does Kubernetes add into the mix? Well, the first thing it does very clearly is it says, rather than as in this model, just calling out to some API with some instruction, go do this thing, it says, you should describe the state that you want your environment to be in with a set of config files. And you should put those in a repository. Right? And then that repository serves as a description of what you want, which Kubernetes doesn't include database schemas, but there's no reason you shouldn't extend it. The way in a Kubernetes world this description is made real is that you submit this thing to an API and it has a while loop effectively that consistently detects the difference and makes it so. Specifically, if you read a lot of the blog posts in this space, if like Weave Flux or this kind of stuff, they make this very explicit by saying you should have something in your cluster that watches a source code repository, and whenever it detects a change, it should kind of pull that thing in. Obviously, Kubernetes also includes some support out of the box for application deployment, so it allows you not to have to script this because it has a thing called a deployment object. It's a bit complicated because the deployment's really often an imperative term, but let's leave that on our own. It also gives you an easy way of defining your own desired declarative state. So you could just as easily say database schema state is a CRD that I define, and I will post the desired database schema state into Kubernetes, and then I will have Kubernetes detect and stomp on the difference. And so for those who put their hand up and it said, this is not the definition of GitOps as you will read in the Weave Works blog post, but I think this is actually, from my perspective, obviously, the simplest way of describing what people talk about when they talk about GitOps. It's really three things. It's having environments as code. When I say environment, why am I saying environments as code and not infra-as-code? Infra-as-code is typically, I will define a template for things. So the classic, a Terraform script or a Puppet manifest or something, and this serves as a template for thousands of servers. But typically when I'm using Puppet or Chef or Terraform, I do not store the state of each individual server separately. So I have the recipe for making my environment, but I don't have the state of the environment defined anywhere itself. Environments as code, or GitOps, says, no, 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 no. You shouldn't just keep the recipe, the source if you like. You should keep the compiled config so that you have a representation of each environment individually. GitOps then adds into that the way to make this configuration happen is you should have a repo watcher. We'll debate about whether that's really necessary or not in a bit. And then it says, well, you remember the business process we had on top? We at Weaveworks found that this works really well if you use GitHub and pull requests. Why not? Like, if you want to keep your tool count simple, defining the process of going from dev to staging to production by saying, I got a bunch of repos, I'm going to open pull requests for approval, it's fine, works. And that essentially is GitOps. So if you read these blog posts, that's what it consists of. A business process defined through Git, environments as code to define the state of your environments, and then repo watching to pull those changes into your Kubernetes cluster. But notice that the way I phrased it here, this is not specific to Kubernetes. Many technologies could work this way if we added a suitable as code representation of what the environment should look like. So I've said this already. I also said the bit about cheating at the bottom. All right. So, deep breath. I'm going to get some water. Now we talk about a straw man. What would this look like in practice? So far we have some idea that we want to store some config. The simple model, I'll get to this in a second. The simple model, of course, in the blog posts is one repo for my environment, because I only have a production environment, so no big deal, and one app repo for my source code, and only one development team. So it looks pretty simple, right? One repo, two repos, one for app code, one for the environment. But the problem, of course, is software development doesn't happen with one environment and one team. Like, the question is, you've got 50 teams, 12 clusters, representing 4 different environments. Okay, now what? So the straw man I'm going to paint here looks a bit like this. We've got 2 teams that are working on different applications that may or may not need to talk to each other. And we have 2 environments, staging and production. In this straw man setup, each team has its own environment for their config and their code, the stuff that they own. And then there is a shared single environment repository with branches for the environments. Now, that obviously introduces interesting access control questions, and this is definitely a model that you can tweak as necessary. I'll talk about why I've chosen this approach in a bit. So within these environments, we have 2 slightly different variants on how these teams are approaching this. I'm introducing 2 variants because I don't think there's an obvious right answer in all situations. Like in the first case, so for those who are not totally familiar with Kubernetes, config is just a config map, which is equivalent to a properties file if you're doing Java or something like that. It's just key value pairs. A service is your front-end ingress, HTTP definition, listen on port 8080 or whatever. And the deployment is a description that says, I want so and so many replicas of this thing, and I want to use this version of the container to boot it up. And then when I have a new version coming along, I want you to transition from the old version to the new version in this way. So what we have in the first setup, this is before any deployments has happened, so it's entirely empty. The team 1 has decided that they want to control the settings for each deployment individually, so they've put them in these branches. And team 2 isn't even using low-level YAML at all. They're using some simplified custom settings thing, like building your own platform as a service. Like a lot of what companies do as their Kubernetes usage grows is that they look at this pile of YAML and they say, oh my God, this is crazy. We don't want all our developers to die under piles of YAML. So we're going to define a simplified abstraction, and then we're going to compile the YAML for them. No big deal. It's like, yeah, if YAML is assembly code, then that's not what we work in at a day-to-day level either, so we compile down to it. Okay, so team 1 wants to update their application, first time. So they have, they make a change. They're going to go from port 80, which was their original thing, to port 8080, and they have this template. It's a template because it has to run across different environments. It has a placeholder there in the bottom. I'm not going to get into the details of how many templating engines could be used or should be used. That's a whole other discussion. Suffice it to say that this is a template. So what happens is this triggers a pipeline, a classic app pipeline. it takes the deployment settings for the staging environment, they're specific to the environment, replaces the placeholders, and makes this thing. It's a file that represents this application as it should live in the staging environment. And that, gets reviewed, gets approved, gets deployed. If it succeeds, we commit it. If it doesn't, we fail, we do some other stuff. And then once we've run our tests and we're happy, we go on to the next environment where we have the similar kind of template replacement. We pull in the production settings for the other environment, which might have a different number of replica sets and so on and so forth. And then we create an entry in that environment as well. And so what we're left with when we're done is we have settings for each environment in the environment repository. And that can be used to represent the desired state in that environment. Now application team 2 comes along, wants to make an update. They have a really, really simple config file. They don't want any Kubernetes details. They only have 3 properties: an application version, a port number, and the image that they're supposed to use. Of course, that also has to be a template because you're going to build the image so you don't know up front what the digest is that you should be using. And you shouldn't be using latest. And you shouldn't be using tags either, really. Best practice is to use digests, not tags. That's not always very easy, but anyway. So here what happens, notice that the config, the environment-specific setting is different. In this case, they've got their config split out per environment. Team 1 had their config in the master branch, which meant that as a template, we only had to have 1, so not much duplication. Team 2 has them in different branches. I'll talk about why this might be interesting in a second, but they now create a similar kind of setup. They've got 2 files in this case. They've got their application settings, and then they've got their config settings. And I'll talk about that app2env YAML, why that would be different from the app2 YAML also in a second. And then they do that again for the other environment, and they're left in a similar kind of setup. So now we've had 2 deployments, we have 2 branches in our env repo, and we can actually diff these very nicely. We'll look at that in a bit. So now an interesting question. Application 2 has gone on fire, and we really, really want to change the log settings to debug, or we want to scale the application up, or we want to do something like that, and we want to do it to production straight away, as quickly as we possibly can. Now, the settings for the production environment live in, if it's scaling, they live in the deployment. If it's config, they live in this config thing. So if you're team 1 and you want to change the config settings for production, you can't really do that without running the whole pipeline because you've got the config shared across all of them. But if you're team 2, where your config is separate for each environment, you can just change the config map in here, go from info to trace. This is a change not on master, but in that branch, and then you have on this branch, you have a different pipeline. You don't trigger the whole application rebuild and wait 45 minutes for all your integration tests to run and all that kind of nonsense. You just go straight, update this file in your environment, and then once you've done that, you've got a quick pipeline that changes this config setting for that specific environment only. You skip the whole staging environment, so you're done. Okay, so that allows you to do this. So there's a trade-off here, notice, that Team 2 has more duplication, in that they have the very similar config in 2 different environments, but they also have more flexibility as a result. Team 1 has less duplication. They have the config in one place, but it's harder for them to make changes to individual environments. And of course, you could argue, well, why don't they change this thing directly? Sure, you could, but then you're in a position where your compiled config is no longer derivable from your source. This is the equivalent almost of SSHing and making that change straight away, and that's regarded as a bad thing in general. Okay, so some points about this. How is this similar or different to other things? This is not hugely complicated. Essentially, well, there are many things here that are similar to what we do with application code. We are considering 2 types of config. The source config, which is what the teams deliver, and the compiled config, which is what actually gets stored and actually represents the runtime state. That's no different from the notion that you would store your source code and you would store your derived code in a different repository. And it's good to keep both for very much the same reasons. In this model, we were going with 1 application repo per team and a shared environment repo for environments. Why? Because more repos generally harder to manage. Repo sprawl is really nasty. Trying to compare 2 environments if their state is in 2 different repositories is much harder than comparing 2 branches against each other. Git does that with a 1-line command. So if you don't have security issues, keeping the number of repos down I think is a nice idea. Branches are good versus folders. So this is a classic one. Why wouldn't you use 2 folders versus branches? Well, branches, it's easier to have different, for instance, in GitHub, you can have different approvals or branch protection settings for different branches. So you can say something like, I have different requirements for production versus staging. That's really hard to do if you have things in different folders, right? And so I'll talk a little bit about the application, the life cycle of the settings. Duplication in general is bad, so minimize it if you can. But if you really need to change settings for an individual environment, put them in a place where you can affect only one environment. So this is this idea that if you really need to change it for one env, you should put it in the env-specific place. And that your source config, the YAML that your teams bring, or the thing that your teams bring, doesn't have to be Kubernetes YAML. Like, it's perfectly legitimate to have a much higher level abstraction to basically build your own Heroku. And then you compile that in this process to the YAML that Kubernetes actually sees. Of course, if you've heard of CRDs, that's taking that a step further. There, the compilation, if you like, happens within the Kubernetes cluster itself. But the key part about creating an abstraction layer remains the same. And this, again, is much the same as we do with application code. We don't all code in assembly. All right. I'll talk now. This is a minor detail. I think one of the bits of GitOps that is not that important is the idea that to get the repo settings into your cluster, you should have something watching the repo. I think it's much simpler to just say, you know what, when you change the repo, just call kubectlf apply. Because A, it's much easier to reproduce. Like, if you want to do it by hand, it's really trivial to do. Plus, you don't have to have some super powerful thing running in your cluster that effectively has root permissions to make all kinds of changes, right? If you have that, then production rights are effectively rights to commits into your repo. You're moving your authorization boundary from your cluster to your repository. And let's face it, Git repositories are really hard to secure in a fine-grained way. For instance, if you give somebody rights to open a pull request, as you need here, they also have commit rights. You know, the TLDR, repos have a very poorly fine-grained access control model. I mean, certainly Git. Okay, blah, blah, blah. Too much text in this case. Wanted to make one final point about config. And the question comes up if you go back to this straw man, oh my God, there's config in so many places. Why is it both on master and then in the environment repos and 2 different files? The reason is that there's different types of config. Right? Often people think of a pipeline as something that's simple. That's a bit too simplified. Application configuration has multiple dimensions. There's the obvious one that we always think about, which is that, oh, I'm going to make a code change, or I'm going to make a config change, like I've got a localized title, and that config change belongs with my application, exists across all the environments. So it's really like this. It's like it's dependent on your application version, and it's independent of your environment, right? So if you wanted to roll back your application, then you would probably also roll back this setting, or you would definitely roll back the code. But of course, there's another variant here, in that you can have settings that are not just application dependent, but they're environment dependent. Nothing sounds very fancy. This is nothing special. This is like logging for a particular environment or scaling policies for a particular environment. Those are different per environment. And sometimes you want to change them independently without running the whole pipeline. I've said that a few times. But you can see there's a suspicious space in this diagram because, of course, there's another dimension that we often do not think about when we think of config. And these are settings that do not share the life cycle of the application. So a classic example is an endpoint for Google Maps or a payment provider. If Stripe changes their API endpoint, and you have that in your application-dependent variables, if you roll back your app's going to break because it's trying to access an endpoint that is no longer accurate. Same goes for things like database endpoints or these kind of settings. So most of the time, you also need to be able to handle settings that should not roll back when the application rolls back. And that's, go through my build, that's what this whole extra file is about. The difference between these 2 files for app2 is those settings that are dependent on the application versus those that are not. By keeping these separate, I can revert the application and keep the environment dependent settings the same, which you can't do if you have all your settings in your application pipeline. Right? That, of course, we all know how this works. Oh no, you make a PR, then you quickly tweak it afterwards, or you patch the thing quickly in, edit in GitHub, and then you make a typo, and then your production thing is badly on fire. Like, that's what we want to avoid with this particular setup. But you may not need it. I mean, not every application has these various dimensions, but most of them do. So going back to, I was talking about 4 higher level processes. This is obviously application update. This is environment config update. And this is also environment config update, but of static configuration, which is why that one lives in the environment repository and the others live in the application repository. All right, talked a lot about that. Now let's look at some of this stuff for real. Very, very theoretical so far. So I could have set this up with lots of servers and tools. I wanted to make this very tool agnostic and very easy for you to play with if you want to. So it's all shell scripts. Super sophisticated, and a bunch of repositories. I'm not going to use the bunch of repositories version of this. I'm actually going to use a version where I'm simulating repositories with folders. That's a bit ugly, but it's quicker because I don't have to do lots of Git checkout stuff. So this is the straw man that we have. We have a couple of repositories, one for each team, and these are branches. You have to think of these as branches, and then this is their master branch. The rest is their master branch. And then you've got the environment repository, which has some input config that I haven't talked about here, and this is where the config actually ends up. You see nothing is deployed, so we're in the same state that we were in my strawman demo. So let's do team 1. Oh, well, actually, no, let's start with team 1. Right, and so we're going to simulate a, what should we do? Yeah, we're going to simulate a deployment. Let's do that. Which ones do we have? We have the app change pipeline. OK, so this is going to pretend to build a container. It's going to generate a random container ID. And it's going to say, here are the config changes that you want to make to this repository. Right? You've got some config settings for the staging environment. You've got a deployment for that environment. It's got one replica. It's got a random ID here for the URL. And then it's got a service that we're going to deploy. Do we want to deploy the staging? Yeah, well, I hope so. Yeah, so this approval could happen in your pipeline. I think there's nothing wrong with doing approvals in your pipeline. But this could also be a PR, if you wanted to a candidate branch or something like that. Right, let's see whether that works. That succeeded, so yay, we did that. Now we moved on to production. We, of course, skip all kinds of integration testing, because who bothers with integration testing? So we run this, and excellent. So we've called kubectl. It was successful, really nice. And so now what we have is we have application settings in one environment. I'm simulating the commits here in suffixes, so that's a bit ugly. But one commit in each environment for application 1. And so a nice thing that we can do now, because we have these in 2 different branches, is we can, for instance, we can really easily diff these 2 environments. Like, notice that diffing the raw YAML already is a little nasty, so you'll want something a bit smarter. But you can see here, got 2 replicas versus 1, dev versus production, got different endpoints, different log settings. You get that kind of for free, right? So that's a nice part of this approach. So now let's go to application team 2, right? And let's have a look at what they have. So this is a slightly, well, let's run their application pipeline as well. Deployment to staging looks good. Deployment to production failed. OK. So because we don't commit to this branch until after the deployment is successful, notice that application 2 isn't running in this environment yet, right? Because it hasn't happened yet. But it is running in staging. So we can see there's application 2. And if I were to run this thing again, let's see, eventually we'll succeed. Notice that I'm now new compilation, new version. So I have a new container ID, fake container ID. And production is a brand new deployment. So I get the full diff again. And it called, oh my God, how many? So this is a 50% chance, I think. So right, I'm going to do this a few more times. Otherwise, I'm going to, can't even hit the right keys anymore. Nervous. Yay, done, successful, great. So now we have both applications deployed to both environments. Lots of attempts for application 2, obviously. Lots of commits in the repo. And once again, I can now, because it's one repository versus, say, the Jenkins X pattern of having every app with its own environment repository, I can now diff both applications across both environments in one go. Right? So here's settings for application 2. there's app1 config, and here's, I don't know, somewhere else the app2 config. So I can see both of these in the same setup, which is very nice. Also, because I have all the settings for all the apps in one environment, if I need to recreate or revert this cluster, it's really simple. I just do a revert, or I just pull all the YAML for any given commit, and I apply it to a new cluster, modulo lots of difficulties, obviously, and I kind of get that out of that as well. So now, let's look at some of the trade-offs that we've made here if we look at how these two teams have set their things up. So team 1, if I look at their settings for, they have the deployment YAML in the environments, right? So I can do something like, let's do app1, production branch. And because I have that, I can very easily, I can change this and say, oh my God, it's on fire. It must scale up to 200 and hope it doesn't blow up. Oh no, one file to edit. OK. Right? And so now, rather than running the whole application, I don't need to rebuild the app. I'm just trying to scale it, right? I could run the whole application pipeline, and that would obviously pick up this config change. But this has happened on a branch. So if you were setting this up, with a real CI/CD server, you would have a different trigger on this that would run a different pipeline. And that pipeline would simply be, OK, let's update production. So I get a single commit straight to production to go from 2 to 200 replicas, done. And now, of course, I can do the same diffing. So I have lots of flexibility about that. But as a trade-off, this deployment YAML in production here looks very similar, unfortunately, to this deployment YAML in this one. So you can't really have your cake and eat it, right? And if I look at the other team, application 2, they don't have their deployment in the environments. They keep it in their config, like they just generate it off a template. But if I'm application 2, right, I go to app 2. Now I want to scale up this thing. Oh no, let's go to, it's in the config. And it's a properties, it's only for the production environment for them. Notice now, because this is on master effectively, I can't run an environment-specific pipeline. I couldn't even hook it up. It's a change to master. What do changes to master do? They run the entire pipeline. And so now I have to rebuild the container, and I have to do an empty deployment to staging. Like there's no changes in staging. Luckily, Kubernetes is hopefully good with this, that it will detect that and not do anything. But if you had a different system that was churning around, you'd be rebooting an app that doesn't need rebooting, which is not great. And so here you see finally we get that config change. We're now at 200 in the production environment as well, but we are also deploying a new version of the application. And that failed, so let's ignore that. OK. I think we walked through a couple of those, talked about some of the trade-offs. Look at the time. Let me go back and see where we get with this. OK. Oh, no. Or was I here? Oh, no, that was not what I wanted. There are lots more little exercises. Oh, that's why. It's the wrong slide. The wrong thing. There are many more exercises in that little folder setup that you can run through, such as restoring environments and that kind of stuff. Very welcome to do that. Well, actually, let's run one more. One more I really like. Let's have a look at my environment repository. So now we have an issue, right? We're going to look at my production repository. If this were a Git commit history, we would just look at, we wouldn't have timestamps, we would have Git commits, but I'm going to pick, I don't know, I'm going to pick this one. Let's pick this time. 1925. So this was deployed at 1925. OK, so now let's go and say, I want to restore, help. Restore environment. OK, so what are the, OK, so I want to restore production. And I want to restore it to, what is today, 2019? 1101. I hope I remember my, huh? Oh, yes, thank you. I'm in the future. Yeah, no, my bad. Thanks for catching that. And what should we say? Let's say 1926. Right, so that should mean app 2 should disappear, right? Oh, well, no, that clearly screwed up. Better never. Well, that bug in my script, I'll figure it out at some point or other. What happens here, obviously, is that, or what is supposed to happen here, is that you can go back to any point in your commit history and you can just pull that out, revert it, classic Git stuff, and then you have that as the new state of your environment. You would never reset, because that loses your history, but you would revert, or you would take that commit and you would put it back at the top. Okay. Sorry, that was a bit confused. So some things that are important to think about if you think about this mental model, right? And this is true of GitOps or whatever kind of setup you think about. The app repository is what drives your deployments. The env repository snapshots your cluster state. It's like a backup state of your laptop or something like that. It represents a known good at the time state of your environment. It's just a checkpoint in time. There are quite a few discussions and blog posts and things that sort of talk about this wonderful notion that your Git repo could effectively be your Kubernetes API, so that you would never have to check your Kubernetes API for anything. Your Git repo would tell you everything you need to know. And that's a dangerous fallacy. That's just not true. Because a cluster can self-evolve. Like, imagine you have something in your Kubernetes cluster that says, I want to change the traffic allocation for this application over the next 12 hours. So you gave it some API stuff at the beginning, but then over the next 12 hours, the state of the cluster changes according to your instructions. So you should not imagine that your repo represents the exact cluster state. It represents, if anything, a contract or a range of bounds for that cluster, and you should think of it that way. Also, that your repository is not a guaranteed healthy state, right? Yes, you can say the Kubernetes API gave me back a 200 on this, but that doesn't mean anything in terms of though that can actually run. Like, your app could be crash looping, could be running out of memory, could be doing all kinds of things. So if you want to use these checkpoints in a serious way, it's very useful to have an additional mechanism to basically tag these commits or identify whether they're really safe or not. And that typically has to be done using awareness of application safety or application goodness, as opposed to just relying on the Kubernetes API to say 200. The last one is a general problem about any kind of declarative system. Terraform has this as well. Kubernetes also has this, and this is just a mental fallacy in general, which is that if you think too much in terms of Git as being what you're doing to the API, there is a tendency to think that if I delete something from my as-code representation, I will delete it from my runtime. That's, of course, not true. Like, if you take a Terraform script or you take an Ansible playbook and you remove a line, that says nothing about whether that thing should be removed in the target or not. It simply says, I don't care about this thing. That sounds a little academic, but it's important in the following case. I've deployed an application, seems to be running fine. I'm cleaning it up. I'm deleting a config map that I think it doesn't need anymore. I commit that, looks fine, deployment looks great, my new as-code GitOps repo looks great. Actually, the app still depends on the config map. I will never find that out because it's still running. So no problem, but if I ever garbage collect that config map, or if I have a disaster recovery scenario when it really matters, I will redeploy a cluster without this config map because I deleted it from my config, and now my app doesn't work anymore. And this is potentially months after that commit happened, so it's really hard for me to track back to oh, I deleted the thing that the app actually needed, but I never found out. There's no easy solutions to this problem, unfortunately. It's basically trying to figure out automatic garbage collection and so on. And the Kubernetes team is working on this. There's a flag, -- prune, which does some really hairy client-side stuff to try to remember, oh, what did I submit last time? Oh, there's something missing. Maybe I should remove that. It's really nasty. And it has 10 million warnings around it. I think it's the flag that has the most warnings in the kubectl documentation. But this is a hard problem. And obviously Ansible tools have solved that. You don't delete a file if you want to remove a service. You put missing or absent, which is an explicit instruction to say make sure this thing is not there. But there is no equivalent in a sort of vanilla GitOps model. All right, I'm getting to the end. OK, that was a straw man. I tried to give you some pointers about how to think about the straw man, what the components are trying to do. But now is where you get your chance to take this and evolve it without, hopefully, cargo culting, evolving it meaningfully for your scenario, your team, your company, whatever. And here I think are the questions that you should think about. Maybe the most important one is what the right level of abstraction is. How much YAML access do we want or need to give our developers? And there's a trade-off here. There's some companies that say we have super smart developers, we want to unlock the full functionality of Kubernetes. They can bring as much YAML as they like. That can lead to 1,400 microservices, each one of which has a totally different runtime pattern. Try to get anyone to debug across applications, and you're going to have a problem. Right? So there's other companies that say this is a crazy idea. We're going to have 5 different ways you can deploy applications to Kubernetes, and that's it. And as a developer, you just choose 1 through 5. Typically what happens is that as companies evolve their understanding of Kubernetes and how it's working for them, and as they grow from like the first 5 or 10 teams to rolling it out for real, your understanding of what the right level of abstraction for you is grows as well. So don't try to over-optimize this for the beginning. Really try it out. But think about this as your adoption pattern scales. And this arguably, I think, is where the key value add of Kubernetes is over something like Heroku back in the day, where the vendor made the abstraction choice for you. And you could take it or leave it. Here you get to make your own abstraction choice, but you really should make that choice. Detailed question about where that abstraction should live. Kubernetes, or CRDs are the sort of the flavor of the month there, which is basically, you define your own custom data types, your own DSL if you like. You have your own parser that lives inside Kubernetes, and you have to maintain it, and it does great things. But template generation is functionally exactly the same approach. You start out with something high level, you translate it into something more low level, but you do that translation before you hit the Kubernetes API. They both have advantages and disadvantages worth thinking about. Templating, this could be an entire 2-hour meetup on its own. What are the right ways to template for Kubernetes or in general? I'm not going to have that discussion now unless somebody really wants to dive into that. There is one interesting, I think, thread of discussion right now where certainly Brian Grant from the Kubernetes team, one of the lead engineers on it, is very adamant that token replacement, the classic notion of having a placeholder somewhere in a file and then substituting that placeholder, is the wrong way to go. And that it's much better to do what used to be XSLT for XML, now customized for Kubernetes. You have a pointer to the thing you want to replace or add, and then you do that. It's like a mix-in. The reason for this in general is that, who here uses Helm? Somebody use Helm? A few people? Okay. So Helm is a package manager which includes a fairly flexible templating engine for Kubernetes manifests. And typically one of 2 things happen. Either somebody has decided they know exactly how this application needs to be deployed, and there's only 3 parameters that you should care about, a bit like in our app2 team example. And then inevitably, one of the things that you need to customize is not one of the things that they cared about. So you're stuck. So you have to, instead of using their definition, you have to clone it, fork it, make your own, whatever. The way people who build Helm charts get around this is that they make everything a variable, so that you can, in principle, customize everything. But the point is that then your properties file looks exactly the same as the YAML file that you came from, because it has one variable for every possible setting. So you've gained no abstraction whatsoever. You've just changed the indentation, basically. And pointer-based replacement allows you to get around this problem. Like, the person who's defining the thing doesn't have to think about what should be tweakable and what should not be tweakable. That's your choice. Of course, it also allows you to break more glass and break more things. So there's a trade-off here as well. When you snap, okay. Okay, so this is kind of complicated and a little tricky. Imagine you're doing an Istio rollout or something like that. You're doing a rollout where your application doesn't get deployed in one go. Like the simplistic notion that my app deployment is just one kubectl call to the API, that's fine for most apps. But if you think about production deployments, typically what you're doing is, well, I'm going to deploy Canary, and then I'm going to wait a while, and then I'm going to add some more traffic to the Canary, and then I'm going to be more confident, and then I'm going to shift some load over, and so on and so forth. So even for just deploying your single application to production, there are multiple config changes that are happening as you do that. Every time you change the traffic shaping thing, you're making a YAML change in an Istio manifest. So if you're doing this through config updates, it's how big is your transaction? This is like a database transaction question. Is your database transaction all the things and you only commit when they're done, or do you commit every small single step? It's not easy, because like with database transactions, if you commit every single step, your repo history, your commit log will be huge. Like one deployment might be 10, 15, 20 commits, which makes it harder to manage. Access control is an obvious problem here. I'm not a huge fan of Jenkins X, but I also don't want to pick on them. I think they've done a great job at making some of this bootstrapping easier. But one, I think, big anti-pattern in a regulated environment is something like the following. If all my approvals are pull requests, then in order to open a pull request, I need commit rights to the repo, unless I'm willing to fork the repo, which most people don't do. If I have commit rights to the repo, I don't actually have to open a pull request at all. I can just commit straight to production. I can commit straight to master. So, and it's very difficult to block this off. Git doesn't have the access control model to allow you to do that. So I think it's totally legitimate not only to ask yourself, okay, do I have different branches or do I have to split this up into different repositories? But you might even think of different technologies other than source code repositories for this. For example, blob stores, they don't have this sort of pretty diff typically, but they have much richer access control capabilities. So I think that's an interesting thing to potentially think about. And then a final thing about Helm. I mainly put this in because Helm is often used in this pipeline as a sort of the classic way you would do this is you would say, let's go back to the vanilla model, blah, here. So we've got Jenkins at the top, and we've got a Helm chart in the app repo, and the Helm chart generates test environment, staging environment, production environment, done. Helm is a distribution tool. It's like apt or yum or anything like that. What are the canonical cases for these tools? So typically, I have my source code. I build this distributable package that I want you to find. I don't give you access to the source code necessarily, but I upload this distributable thing somewhere where it can be found. And then somebody else in my company or even in a totally different company downloads it and installs it in their own environment. And if you're doing that with Kubernetes style stuff, Helm is perfect. It allows you to bundle and package and give it a version number and upload it to a repository, and someone else can download it and use it. And so if you have a company internal Elastic in an Elk stack or something that you want to run, Helm is perfect for that. But if you're deploying your own app to your own environment that you fully control, like if you think back to Java or NPM or Python or whatever deployments, we didn't typically, for our own apps, wrap up our Python thing in apt, only then to call apt-get, apt-get publish, apt-get update. Sometimes we did, and we tried that. It was very uncommon with Java, for example, but maybe common in other languages. The reason we don't need to do this is because A, we already have the code, so we don't need to publish it somewhere, only to pull it down again. And B, all the mechanism of bundling, like making fake versions for everything, because you already have a version, it's a commit. And you already have the code because it's a repo. So you don't need any of the richness of the publishing and then downloading and installation mechanism. The reason Helm is still very popular, and I think a genuinely good choice for many of these use cases, is because it has a rich templating thing. But you can use Helm very easily in combination with that by just going Helm dry run, which creates, I'm almost done by the way, sorry for everyone who says, no, that's fine. Yeah. Helm dry run to generate the YAML, and then you can just apply that YAML with kubectl apply. And I think then you're getting the best of both worlds. Like you get the templating richness, but you also don't get the overhead of a flaky repo that you don't need, and synthetic versions that you don't really have to create. All right, blah, 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 blah. It's late, I've probably run over, so I'm not going to belabor this too much. This is some nice homework stuff. If you're interested in taking this forward, that's a kind of step-by-step thing you can do. Thank you very much. Right. In the interest of time, probably not lots of Q&A, but if somebody does have a question, it's warm in here as well. But there's a mic at the back. If you do have questions, please feel free to ask them or catch me in a second.
Hi, sorry. Can you go back to your slide, I think number 3, you're talking about the access control with Git and why it's not a good idea to...
Which one? Which one?
The one where I think you said you shouldn't use the one with the number 3 on the top.
Oh, the number 3. Okay. Yeah? Sorry. Probably not this one? No, neither
yeah,
of
that
those.
one. The one with the commit after.
Oh, that. Oh, okay, the bottom one?
Yeah.
Okay.
Can you explain that point
Sure.
a little bit more?
Yeah, yeah.
If you-
Sorry. This is less to do. So this is. If you look at Kelsey Hightower's, he has a demo setup that is similar, but in some ways importantly different from this. Or if you look at the Weaveworks blog post, the way they do the business process is they do the following. They say, okay, built my app, generated my YAML. Now I want to deploy the staging. So I open a pull request against a repo, the staging repo, against master, right? And then I leave it there. That's fine. And then when I approve, the way to actually deploy to the staging environment is to hit approve and merge. And then once it's merged, you have your GitOpsy thing, your Weave Flux in a cluster pulling in that change. This is commit before apply, right? So you merge into master before you've actually applied it. My jokey term for it is merge and pray, right? There's not a problem as such. The thing to realize is that you are merging something into master without having any idea about whether it's going to work. So master in this scenario does not represent a history of successful commits. It represents a history of attempts. And if you want to use this repo as a recovery mechanism, for instance, you better have a way of distinguishing which of those commits were successful and which of those commits were failed. You can do that through labeling, or you can do that through magic comments added to the PR afterwards or whatever. My preferred mechanism, if you really want to do this, is that you have two branches, candidate and master, and that you open the PR against candidate. And then you merge, and then that represents your attempts. They're called candidates. And then if you actually succeed, you cherry pick from there into master. So then you have kind of the best of both worlds. More branches, a bit ugly, but that's what I meant with this. You can totally do it, but I think everybody needs to understand that your branch represents attempts. It's just to have the right mental model.
So what's the better way to, like, can you do it before merging into master? Can you deploy and then?
So there's a couple of ways. So one of the things Google does internally, with a similar pattern, is that when you open that pull request to master, much more validation happens about whether this deployment is likely to succeed. Like the problem, if you like, or one of the challenges with the merge and pray thing is that what are you reviewing? Like you're looking at a change in YAML. Oh, good, one digest changes to another digest. Could mean anything, right? There's really no way for you to have much confidence up front that something successful is going to happen here. So one way I think you can do it is have a lot of basically dry run deployment triggered on the pull request being open so that it's less of a merge and pray and more like I'm almost totally confident this is going to succeed. I think another possibility is to say, I am going to try the deployment on the approve, not on the merge, right? And then I am going to try the deployment and I'm going to merge only if the deployment succeeded. Or indeed you have staggered branches. So you have a candidate branch that represents what you're trying and a master branch that represents what actually worked.
Okay, thank you.
Cool. I think everybody's tired out. Everyone wants to go home. That's great. Thanks very much.
So huge thank you to Andrew. Thank you everybody for coming. Hope you had a great time. I'm sure Andrew's around for questions afterwards if you want to chat some more. I'm here for questions as well if you want. Thanks. And if you have any ideas that you'd like to see next year, definitely come talk to me. Have a good night.